Today we're going to talk about vertex form. Yesterday we did an introduction to the quadratic graph, and so here I'd like you to just take a minute, pause the video, and label all these different things on these two graphs. So label the vertex, not asking for you to label the point itself, just to identify where's the vertex, is it a maximum or a minimum, where's the axis of symmetry, the y-intercept, and the x-intercepts, and just fill in the boxes. Once you've identified all the places, then go in and add the values. There are two graphs on the right-hand side, graph A and graph B. Graph A is blue, graph B is red, and take a moment and try to fill in the table, which is very similar to what we did on the other slide, and fill in the table for each of these lines or curves, for each of these quadratic parabolas. I have indicated with large gray dots the areas of interest that you should be labeling. There are the results for graph A. And there are all the points for graph B. Remember that our vertex is the point where the graph turns on itself. That is where we find the maximum or the minimum. It is where we find the axis of symmetry. And then, of course, there are the x-intercepts and the y-intercept, which is where I'm crossing the x and the y-axis. Mentioned before, there are three different forms of the equation for a parabola. So there is the vertex form, which is the one at the top. This tells us exactly where the vertex is. So when it says the general form, that is the generic form, so with letters substituted in for the numbers. And that general form is y equals a bracket x minus h bracket squared plus k. And this form tells us the vertex. So it gives us the vertex, and the vertex is hk. So notice how in the equation it's negative h and the vertex is actually positive h. So what it says is that the h value or the x value of the vertex is in the opposite sign to what it is in the equation. It gives us the direction of opening, because if A is positive, it opens up, and if A is negative, it opens down. Then we have the standard form of the equation. This is the one that we've been using to factor. So this is the one right here, right, where we have ax squared plus bx plus c. This form can tell us two things. It can give us the y-intercept, because remember that the y-intercept is the value of y when x is 0. And if x is 0, then that means that those two terms disappear, because anything times 0 is 0. So it gives us the y-intercept, and it gives us the direction of opening. And then finally we have factored form. And of course we get factored form by factoring. These, by the way, are all the same equation, just in the different forms. So note how this factored, so x squared plus 6x plus 5 factored is x plus 5x plus 1. And so the generic factored form just replaces the 5 and the 1 with letters. And the factored form, of course, gives us the zeros, and it also gives us the direction of opening. Notice how A is in every single general form. It's a bracket x minus h squared plus k, and it's a x squared plus bx plus c, and it's a bracket x minus r bracket x minus s. So the a is in every form of the equation, and it is always there to tell us the direction of opening. So take a minute to think about that, and what these different forms tell you, and why sometimes it might be better to have one form over another. Here are 4 different equations. They are in different forms. Take a minute, pause the video, and determine for yourself what form are they in? Is it factored form? Is it vertex form? Is it standard form? And there you have it. Note that in C, there's an A value that is not 1. Well, don't let that throw you off. It's still pointing up. It has zeros at positive 17 and negative 5, and it is in factored form. So that's C. Sorry, I started at C instead of A just because of that interesting A value there. The A graph, or the A equation, tells me that I have zeros at positive 3 and negative 2, because the zeros are just like the H in the vertex form. They are the opposite sign on the graph that they are in the equation, because, of course, what makes x minus 3 equal 0? Well, that's positive 3. What makes x plus 2 equal 0? Negative 2. So the zeros are positive 3 and negative 2. B is in standard form. I know that the y-intercept is negative 41, and I know that it points up because the 16 is positive. We've already talked about C, and of course D is in vertex form. I know that the vertex is negative 2, negative 8, and I know that it opens down because the A value was negative. So the coordinates of a vertex from vertex form, of course, are HK. So H is the x value of the vertex, comes from the equation, but it has the opposite sign. So we get the H value from this part of the equation here, but it's negative H in the equation, which means it flips the sign in the vertex. And the K value just comes right from the equation, and it keeps the same sign, and that is the Y value of the vertex. So when A is positive, the graph opens up. When the A value is negative, it opens down. And we can get the y-intercept, because of course that is the value of y when x is 0, just by substituting 0 in for x and then solving for y. And now it is time for you to do some practice.